Finding the area between two curves can be hard enough as it is, but what happens when they give you what the area is supposed to be and the curves themselves have unknown constants in them? That can make it even more challenging when you have to kind of work your way backwards. So today I wanted to show you a portion of one of my live streams, which I do every Monday night at 5 o'clock Pacific, where I went over an example that says something along the lines of find the constant c in order to make the area between these two curves, which contain that constant c, a specific number. I thought you might find this example helpful, so I wanted to kind of show you that portion of that live stream again and take a little more time to focus on that kind of a problem. This is one of the topics covered in my integral calculus cheat sheet or my calculus 2 study guide. If you want to check that out, there is a link down in the description below. But without further ado, let's go ahead and jump into the example and I'll show you how to do this kind of problem. The problem tells us to find the values of c such that the area of the region bounded by the parabolas y equals x squared minus c squared and y equals c squared minus x squared is 576. So this is kind of an interesting problem because they give you these two different equations of the functions that we're trying to find the area between them, but they both have this c squared term in here, which is kind of different. You don't really see that too often, but what you want to kind of keep in mind with this is the c is going to be treated as a constant. So there isn't necessarily anything that tells us that c is a constant and x is a variable, except for just kind of the common expectation or the common notation that usually you have like y equals some function of x. So as a result of that, typically if you have y's and x's and then some other letter, the x is going to be your input variable or your independent variable. The y is going to be your output variable or your dependent variable. And then the other letter is going to be a constant. And like I said, there definitely are situations where that is not the case. Usually if they don't specify or don't give you any context clues that would tell you that, you can pretty safely assume that x is going to be your input variable, y is going to be your output, and other letters, especially c is a very common one, would be constants. So what we should do first of all is just kind of draw a sketch of what we're dealing with here. So let's go ahead and start with that. Let's think about what each of these functions are going to look like. So first we'll start here, y equals x squared minus c squared. So like I said, x is our variable. So basically we have x squared minus some constant, right? So just imagine, what if we had like x squared minus 9, for example. 9 is just some number, just like c squared would be just some number. We don't know what c is. C is what we're trying to figure out, but whatever number c is, it's going to give us something that looks like this, right? Where we just have x squared minus some number. So as a result, what we can kind of do is think about what this will look like. Well, this is just going to be a parabola since we have an x squared term and then just a constant. The x squared term is positive, so we know it's going to be an upward facing parabola. So it's going to have generally this kind of a shape. And then it's going to be moved down, in this case, 9 units. In this case, it's going to be c squared units. But there is one thing really important here. C squared is always going to be positive, right? Just looking at c squared itself, this is always going to be positive because any number, whether you have a positive number or a negative number squared, it makes it positive. So c squared is going to be positive. So if we have x squared minus a positive number or x squared minus something like x squared minus 9, for example, we know we're going to have an upward facing parabola that is shifted down some number of units. So if we just had x squared, the function x squared, it would look something like this. And that was a pretty terrible sketch. It would look something like this. But since we have x squared minus some positive number, basically that's just going to shift this down some number of units. So basically, we would have something down here. And how many units is it going to shift it down is kind of the next logical question. Well, it's going to shift it down c squared units. So basically we know that this vertex here is going to be at c squared or negative c squared actually. So basically we know that this function is going to look something like this. We could actually even figure out where this intersects here, but I'll come back to that a little bit later because that's going to be relevant in a later step. So now let's think about what this function looks like. So in this case, we have c squared, some constant squared, minus x squared. So that's, kind of similar to what we had over here, except in this case, now we have our constant being positive. Instead of over here, we had minus some constant. And then our x squared term is now negative. So what that's going to do whenever you have this kind of a thing, we could also think of this as y equals negative x squared plus c squared. That's the same exact function. Since our x squared term here, since x is our variable, our x squared term has a negative coefficient. This one is going to be facing downward like that. It's going to be a downward facing parabola, where now the number that's being added, again, since c squared is always positive, any number squared is always positive. Now that we have a downward facing parabola plus a positive number, it's going to be shifted up c squared units. So very similar to what we had here. Now we're going to have a parabola which is shifted up c squared units and then comes down like this. And then again, since we shifted it up c squared units, this vertex here is at positive c squared. So this is kind of what our function or these two functions are going to be looking like. The question obviously is, how do we find the area between these two functions if we don't know what c squared is or what c is? Well, let's start with the formula for the area between two curves. And like I said, this is one of the formulas that's on my integral calculus cheat sheet. There's a link down in the description or in the pinned comment below. But that formula from my study guide basically tells us that if we want to find the area between two curves, so the area between two curves is going to be given by the integral of, and this isn't exactly the notation I use on my study guide. It goes into a little bit more detail in writing. But basically what we want to do is we want to integrate our top function minus our bottom function is essentially what it comes down to. So you can see throughout this area trapped between these two curves here, let's actually go ahead and even shade it in a little bit. We basically have this area in here. This is, you can kind of see throughout this whole area. If we imagine for a second, a red, we'll make it red so we can kind of distinguish between them. A vertical line that, let me grab this here. A vertical line moving throughout our area from left to right. So from over here at the left edge over to the right edge. If you imagine, and I didn't quite make this long enough, but you can kind of imagine this vertical line extending further so that it actually goes across the whole area. You can imagine this vertical line sliding across our area, and basically where this vertical line intersects with the edge of this shaded area is what we want to consider the top and the bottom. That's how we kind of figure it out. Basically, as this vertical line goes across, you can see, let's take a snapshot right here, for example. You can see that the top of this green shaded area is made up by this function right here, which is intersecting with our red line right here, our vertical line right here. And then same idea here. If we look at the bottom of this area, it intersects with this function down here. So what you notice as this vertical line goes across is the top edge of this area is always going to be this parabola here, all the way through from left to right edge. And then the bottom edge of this area is always going to be this parabola here. So it's consistent all the way through that this downward facing parabola is the top of our area, and this upward facing parabola is the bottom function of our area. So if we are going to find the area of this this area between these two curves, it's just going to be this top function, which is c squared minus x squared, minus this bottom function, which is x squared minus c squared. So minus, make sure you put this all in parentheses, minus x squared minus c squared. Okay, it is very important that this bottom function is in parentheses here, because if it is not, this negative sign is not going to properly distribute, and you're going to get the wrong number. So the other piece that we need to figure out now is the bounds of our integral. Well, the bounds of our integral are just going to be whatever x value is the left edge of our area and the right edge of our area. Well, like I said earlier, we would come back to figuring out where these parabolas intersect with the x-axis, or in other words, where they intersect with each other. In order to figure out where two functions intersect with each other, all you have to do is set them equal to each other. That's all it really comes down to. So what we can do is we can take x squared minus c squared, which is one of our functions, and set it equal to c squared minus x squared, which is the other one. And then keep in mind, what these bounds need to be is x values. We're integrating this with respect to x. So these need to be x values. So we need to solve this equation for x. It's fine if our answer has c's in it, because we don't know what c is. We can't possibly say that, say what number this is where these intersect with each other. But we can say what it is in terms of this unknown constant c. So we just need to take this equation and solve it for x. So let's move all of our x's onto one side, all the c's over to the other side. So we'll add c squared to both sides. We'll add x squared to both sides. So we get x squared plus x squared is 2x squared. C squared plus c squared is 2c squared. This cancels with this. This cancels with this. Then we can divide both sides by 2, getting x squared equals c squared. And then we can take the positive and negative square root of both sides, giving us x equals plus or minus the square root of c squared. The square root and the squared are going to cancel, giving us plus or minus c. So basically, this point right here is positive c, and this point right here is negative c. So that was important when you take the square root of both sides of an equation to solve for a variable like this. You do need to take the positive and negative square root in order to account for both of those. So basically what that tells us is that the left edge of this region is negative c, so that's going to be our lower bound, and the right edge of this region is positive c, so that's going to be our upper bound. So now you're probably looking at this integral and thinking, well, what the heck are we supposed to do with x's and c's? That doesn't make any sense. But keep in mind, there's still one more piece of information that our problem told us that we have not accounted for yet, and that is right here. We already know that the area of this region is 576. So if this equation is meant to represent the area of this region, we already know what this is equal to. We're not actually trying to solve for this here, we're trying to solve for c. We already know what this integral is equal to. It's going to be equal to 576. So kind of a weird situation there. Usually when you're trying to use this area between two curves equation, you're solving for the area, but in this case we know the area. We're trying to solve for this other unknown constant. So what we can do now is we can simplify this integral. So to simplify this, we'll go ahead and distribute the negative sign. So that'll give us, this stuff isn't going to change out here, but negative x squared. So the negative distributes in there, and then the negative will distribute in here. Negative, negative are going to cancel. We're going to get plus c squared. Then we can combine our like terms. So we have negative x squared minus x squared is minus 2x squared. C squared plus c squared is plus 2c squared. So now we can go ahead and integrate this. So to integrate this, we can actually just do that with the power rule. So the power rule says that, whenever you have an x raised up to some power term like we have here, we can raise the power by 1, so making it x cubed, increase our power by 1, and then divide by our new power. So negative 2 is going to remain our coefficient, and then we'll divide by our new power, which is 3. So then this one, keep in mind, c is a constant. So if c is a constant, if c is some constant number that's not changing, that constant number squared is still a constant, and that constant times 2 is still a constant. So if you just multiply a bunch of constants together, or add or subtract a bunch of constants that are not variables, you still just end up with a constant. So this whole plus 2c squared term right here, this is just one big constant. So the reason why I bring that up is, well, how do you integrate a constant? Well, the integral of a constant is just that constant times x. So that is the integral there. And then we need to evaluate this from negative c to positive c. So in order to do that, we're just going to go into our equation and replace our x's with the upper bound, and then go back in and replace our x's with the lower bound. So we will get, first plugging in c, so we're going to get negative 2/3 times c cubed plus 2 times c squared times c. C squared times c is just c cubed, so plus 2c cubed, and then minus parentheses, plugging in our lower bound. So now we're going to plug in negative c for x. So we're going to get negative 2/3 times negative c cubed plus 2c squared times negative c. Okay, so now we want to simplify this because this is a bit of a mess at this point. So to simplify this, first of all, negative c cubed is going to be just negative c cubed. Cubing the negative sign is going to keep it negative, and then cubing the c is going to make c cubed. So we're going to have basically this is negative c cubed. Similarly over here, this c squared times negative c is also going to give us negative c cubed. So basically, to simplify this, just what's in the parentheses here, we're going to have negative 2/3 times negative c cubed, which is the negatives are going to cancel, giving us positive 2/3 c cubed. We have plus 2 times negative c cubed, which is going to be minus 2c cubed. And then remember, all this is just going to remain the same for now. Okay, so now we want to distribute our negative sign into the parentheses here. So we're going to get negative 2/3 c cubed, negative and negative cancel, giving us plus 2c cubed. All this will leave the same. Keep making it a 5, but it's a 6, 576. Okay, so now we can combine our like terms. So now notice one thing that is very important. At this point, we have evaluated the integral from our lower bound to our upper bound. Typically, when you evaluate a definite integral with upper bounds and lower bounds like that, once you have evaluated the integral, once you have integrated this function and then plugged in the upper bound, plugged in the lower bound, and subtracted them, you should have a number. There should be no more variables left. What do you notice about this equation? There's no x's left. We only have these c cubed terms in here. Well, since c is a constant, again, c squared or c cubed or c to any power times any other number is still a constant. So we still just have a number over here. So we have evaluated the integral and we've gotten it down to a number. Of course, what the question asked us to find was find the values of c that make this work. So we need to find c. However, it is important to notice that we don't have variables here. We have basically integrated out our variables. We just have this constant that we're trying to solve for. So basically, we just have a bunch of c cubed terms being added together. Let's think about what they are. We have a 2 plus a 2, so that gives us 4. Minus 2/3 gives us minus 4/3. So basically, 4 minus 4/3 is our coefficient. If we were to get a like denominator here, we would make this 12/3 minus 4/3. So that gives us 8/3. So basically 576 equals 8/3 c cubed. And then we could multiply both sides by 3/8. So we would get 3 times 576 over 8 equals c cubed. And then to solve for c, we would just have to take the cube root of both sides. So that gives us c equals the cube root of 3 times 576 all over 8. So I'll go ahead and leave this for you to finish up. All you really have to do at this point is just plug it into a calculator. If it were a test and you had to leave this in exact form, I'd probably just leave it where it is right there. Well, I hope you found this video helpful. If you did, please be sure to hit that like button down below and hit that subscribe button and that bell icon as well so you're notified of all my new videos and when I'm going live each week. Like I said, this problem came from one of my weekly live streams. Every Monday night at 5 o'clock Pacific, I go live. So be sure to join us on Monday night for the next one. You can get some questions answered live and maybe get to know me and the other members of the Jake's Math Lessons community a bit better. So hope to see you there. And if you want to keep learning about how to find the area between two curves, just go ahead and click on one of those videos over there, and I'll see you next time.